Hi, my name is Gülce Yalçın. I'm currently doing my postdoc with the plankton group at IGB Germany, but today I will talk about my PhD studies at METÜ Turkey with Limnology team. And the title of the talk is Combining eDNA and Image Analyses to Determine the Impacts of Warming and Dissolved Organic Carbon Disturbance on Freshwater Communities. I want to start with background and hypothesis, then I will move on to methods, which are mesocosm experiment, flowchem, and eDNA. Then lastly, I will talk about major findings of this research. Due to the increased frequency of extreme events like flash floods, lakes are receiving more dissolved organic carbon. Again, as a result of climate change, lakes experience increased air and water temperatures. Therefore, combined effects are there in the nature. However, in the literature, it's very underrepresented, especially on bacteria and slates. Elevated temperature and DOC would synergistically increase bacterial biomass and shift community structure, would influence slate biomass and composition, and would promote mixotrophs in phytoplankton due to DOC's light limiting effect. In order to test combined and separate effects of warming and DOC in lakes, we performed a mesocosm experiment with heating, DOC, and combined treatments, H, D, and HD. For heating, we performed +4 degrees warming in the mesocosms, and for DOC, we added TDOC source produced from alder tree leaves. In order to enumerate and identify bacteria, slates, and phytoplankton, we combined imaging techniques with eDNA. For the imaging techniques, we use microscopy and flowchem, and for eDNA, we use 16S and 18S rRNA next generation sequencing. Major findings are there were no synergistic impacts for bacteria because heating did not have an effect at all for the bacteria, but rather impacts were through DOC. Slate responded with functional groups, again majorly in DOC-bearing treatments. Phytoplankton showed significant shift in all treatments without a proof of mixotrophy increase. And let me show you in detail why there were no synergistic impacts for bacteria. On the left-hand side, you can see that bacterial biomass was only significant for D and mixed treatments with nonlinear patterns of increase followed by a decrease. On the right-hand side, you can see 16S rRNA results showing Gammatoproteobacteria dominance significantly in DOC treatment proved by ANOVA. And if you look at the Bray-Curtis dissimilarity, it also showed that the composition significantly altered for only D and HD treatments. Now let's look at how slates responded with functional groups. On the left-hand side, you can see the result from the flowchem analysis showing that the increase in D was significant, while H and HD heating and mixed treatment did not show any significant effect. And when we look at the functional groups, we saw that the increase was from bacterivore slates. So slates responded mainly through functional groups. Phytoplankton results suggest that there was a significant change in both treatments. However, although there was a change in composition for all microeukaryotes, there is not an evident pattern yet to be found for the mixotroph classes of phytoplankton. For that, we will keep further analysis. I want to thank all my team members for their support and help, and my advisors, Meryem and Eric, for their guidance. If you have any questions, please email me or just get in touch through the ResearchGate, LinkedIn, or Blue Sky accounts.